Hello, and welcome to the Trepid Technologies Security Plus course. My name is Johnny Bannon, and I will be your instructor for this video series. This video will cover Domain 2.5. Now let's get started. Resilience in the network is vital for business operations and continuity. It is the responsibility of the IT team and cybersecurity professionals to ensure business objectives are met and that the lights stay on, right? That's the important thing, an important duty in our role as cybersecurity professional. We must make sure we stay up so we can continue to make profits for our organization and be a successful company. We can achieve this by creating resilience in the network so that our systems can stay on when there is an outage. Replication is an essential part of having resilience in your network, as is redundancy. In the next few slides, we will go over different technologies and techniques used for replication, redundancy, and resilience. So the first thing we're going to talk about is a storage area network, or SAN. A storage area network is a network technology and design that provides block-level access to data storage. A SAN system will deliver files and data in blocks or chunks. So when we use a SAN, we store and deliver data in chunks, right? Or when we retrieve data, it comes in chunks or big blocks of data instead of individual bits or files. SAN systems are considered robust, and generally they're going to be used in large enterprises that require scalability and a mass amount of storage. SAN storage is commonly used in virtual environments as the data store to host and store all your VM files and data, and they'll also be used for the user's network shares, right, or storage. So common providers that you're going to see out there in the enterprise: NetApp, Dell EMC, some of the big names in SAN. And this, again, is such a deep topic that the Security Plus exam just barely skims the surface of. There is SAN engineers that spend their whole life in technology working in storage, right? Just like there's network or system engineers. So SAN, again, for the Security Plus exam, you need to know that it's robust. It's used in the large enterprise, typically, right? And you have to know that it's block level storage. And this will make more sense when we go over NAS, or network attached storage, which is file level. And then we have our different backups. So again, to have that redundancy and that resilience, we need to back up data. So backing up your data is vital to having resiliency on your network. As a cybersecurity administrator, it is your job to ensure data availability on your network/enterprise. Remember, the thing that guides us, the CIA triad. Availability is still part of it, something cybersecurity professionals tend to forget. If your data gets corrupted by a virus or malware, backing up your data could save your butt, right? When you restore to a known good without that virus. In case of drive failure, you also want to make sure you're backing up your data maybe to something off-prem, right? So you want to have that redundancy in our backups. So there are many different ways to back up your data. The Security Plus exam will cover different techniques for on-premise and off-premise backing up your data, but now let's go into some more specifics. A full backup captures your data, the entire system, or the entire drive. A full backup backs up everything, right? If I'm backing up my accounting department's file share and it's 1 terabyte, I'm backing up that 1 terabyte. So a full backup takes the longest, but it is the most reliable. And typically these full backups, since they require so much resources, computing resources that is, they're not going to be performed during peak hours of operation. So you may want to do your full backup maybe from like 2 a.m. to 8 a.m. and maybe on the weekends, right? And then we have incremental backups. Incremental backups will only capture the changes since the last backup that was performed. Now, we didn't say the last full, we just said the last backup, right? So let's say we didn't perform a full backup. Well, incremental backup will still only capture the changes since that last backup, okay? And this will make more sense when we get into differential. A differential backup will only back up the new changes made after a full backup. right? So that's the difference between incremental and differential. So full backup and differential backups are usually used together in a backup system or deployment or implementation, right? And then we have a snapshot. So a snapshot is another technique for backing up data. A snapshot will capture the last known good state of a virtual machine. And now this is not something automatic, right? Let's say on Monday you do a snapshot and the VM was working, that's the last known good. So taking a snapshot of a virtual machine will also save you if changes go wrong in the network. Let me paint a picture for you, an example. So imagine you are performing a patch on a Windows server, and maybe that Windows server runs the DHCP service. So we have our DHCP server here, and let's say this is a VM, right? So maybe in this hypervisor we have so many other VMs running, but we have our virtual machine here. Got that connected to our switch, and all of our users, including let's say our C-level executives, are using this DHCP server to get IP addressing. You decided to run this patch for the Windows server operating system during operational hours, right? Because the vendor assured you, your Microsoft vendor, whoever, right, that there are no flaws in this patch or this upgrade. Well, after the patch, users start complaining that their devices can't reach the internet. And the level 1 help desk technician informs you that workstations are not receiving an IP address or they're getting in a PIPA, right? Which is that 169. Now, if you're a good cyber or system administrator, you'll say, oh, perfect. I took a snapshot of the virtual machine before the upgrade. But if you didn't, now you have no rollback plan. And now you just got to go through with either building a new DHCP service or finding another way to get those users online, right? Maybe you go through the important ones, give a static while you figure out why the patch didn't work. So snapshots can save you. Typically, right, another concept in this, implement your changes during an outage window where you can fix bugs, right? All right, moving on. Now let's go to different forms of backup media. So in your enterprise, different types of media may be used for storage. In most modern networks, you're going to see hard drives and solid state drives on your end user devices, on the servers for your storage. But we must understand and know about the different forms of media that we can use for backups. Why? Because you may see it out there in the real world and because it's on your exam. So the first thing we're going to go over is tapes. Tapes are still used in some legacy systems for backups. Important things to know for about tapes, they can never be written over. So they are very safe form media for integrity, but they do not have large storage capacities. If you're using tape to back up data, you'll need a system that can hold and house that much tape. So think about, for any Star Wars fans out there, that scene in Rogue One, right? Where it had all those different tapes of data backup. You need a lot of storage for this. And we mean physical storage of using tapes. And then we have disks. Disks are still the most common form of media backups. Disks are used in most storage systems, whether that's magnetic hard drives or solid state drives, right? So when we say disk, we mean hard drives or solid state drive disks, not DVDs or Blu-ray. Optical media is a term we're going to use to describe DVDs or Blu-ray discs that can be used as backup media. And now let's go over NAS. Network attached storage is similar to SAN, but does not provide block level storage. NAS is going to deliver data in files, thus providing what we call file level storage, right? I know your brain just exploded. NAS is typically used in small to mid-sized networks that do not require the robustness of a storage area network. So we can see here, maybe we have just a strip mall outlet store, right? Maybe there's 4 employees, 5 employees, and we'll have a little file share on a NAS, right? A lot of homes will have NAS. So I have Western Digital, like 2 terabyte NAS storage on my network. Very common for just small to mid-sized businesses. All right, and then cloud storage. So using the cloud as a storage and backup method is now very common in today's networks or your enterprise. And as a cybersecurity administrator, you must adequately vet the security controls used in the cloud to ensure that if you back up customer data, that cloud service provider is adhering to data governance and data sovereignty. So things to think about when using the cloud. If you got customers in the EU, remember their rules, the GDPR, data rights protections, right? You must also make sure that users are not storing IP, meaning intellectual property, in public clouds, right? So intellectual property, that's what IP stands for. When talking about intellectual property, that's the acronym, not Internet Protocol, right? Intellectual property. And if you use iCloud or Google Drive, that is using cloud storage. So you guys, the common user, someone with an iPhone, uses cloud storage all the time, which is a lot easier for the consumer than installing and maintaining their own storage, right? And then we have a computer image. So what is a computer image? A computer image is used to install an operating system on a computer or a hardware, right? This is a bootable pre-configured operating system. So what do I mean by that? Well, when I want to install Windows 11 on my laptop, right, I use a bootable image or a computer image to put that ISO file onto the hard drive to give an operating system to that hardware, right? A computer image can also be used to create a standard baseline for your enterprise. Meaning when I create that Windows 10 image, I can put policies in place or give a desktop background in that image so that image can be used for maybe for everyone in the accounting department or the marketing department, right? A computer image can sometimes also be deployed from the network in deployment systems like Microsoft SCCM or Windows Deployment Service. This is where you make a pre-execution environment or pre-executable environment called Pixie, and your users via DHCP and TFTP will be able to run an operating system over the LAN and install it over the LAN. And then we have high availability. So this is another redundancy in a cloud concept. High availability is a significant advantage that cloud service providers can provide to your enterprise. Since cloud service providers have geographically diverse data centers spanning different continents, you can deploy applications or services or storage across different zones, right? These zones being geographically dispersed, and this is a cloud term, to support customers internationally. So these zones will have these data centers, right? And you can put your storage, your data in all these data centers. Well, maybe one's in Virginia on the East Coast, one's in California on the West Coast, and one's in Iowa in the Central, talking America, right? This also gives you redundancy during a natural disaster, right? Because now you have data centers all across the continent. And then, of course, geographical dispersal ensures that a single natural disaster will not destroy all the data in your enterprise. In the CompTIA exam book, it says that 90 miles is the safe dispersal distance for redundant data centers. All right, now let's move on to RAID. So let's take a deep breath before we go over RAID, right? Because this is always a concept that was hard for me to learn when I was first starting out and studying. But RAID is a very important replication and redundancy technology that we use. So let's go ahead and jump right into it. RAID, or a redundant array of inexpensive disk, as it stands for, allows your computer or systems to recognize multiple disks as one logical storage drive. So if we have two disks here, your computer, your system is going to recognize this as one storage area, and that'll maybe be like your F drive or your G drive, right? RAID has many different ways of creating redundancy among your drives. So we can see here we have disk 0, disk 1, and there's 8 drives amongst them both. So how do we create redundancy amongst those drives? Well, RAID 0 is going to use something called striping. RAID 1 uses something called mirroring. And then RAID 5 and 6, which we'll get into, we'll use something called striping with parity. And then we have RAID 10 and 50, which are going to combine all three: parity, striping, and mirroring. Let me write that better. Parity. So now let's go over our different RAID implementations. So RAID 1 is the easiest one to first learn when discussing RAIDs. That's what we're going to go over. RAID 1 uses something called mirroring to create data redundancy in your drives. For example, let's say you have two 1 terabyte drives. So this is a terabyte and this is a terabyte. If you configure these drives for RAID 1, you'll still only have 1 terabyte of space because RAID 1 will mirror data from one drive to the other. So if a drive fails, you still have all your data, right? So let's go over this. So if I save a file here, right? Again, this is all one logical device or disk to your systems. But if a file gets stored in this disk right here, it's also going to get stored here. It's called mirroring. So even though we have two 1 terabyte disks or drives, which should give us 2 terabytes capability, right? Well, if you implement RAID 1, you really only have 1 terabyte of storage. So some disadvantages are decreased storage space, and you're going to have slower write times because you'll have to write data twice. RAID 0 will deliver higher speeds because they do not mirror drives. RAID 0 performs something called striping. This will save data bit by bit among all the drives in your RAID, which is all logically one drive, right? RAID 0 is going to provide faster write speeds, but that's really the only thing it provides. RAID 0 is aptly named because it provides zero redundancy. Because if you lose one drive, you lose all your data. Now let's move on to RAID 5. RAID 5 will also use striping to write data, but with RAID 5, we use parity bits, which are calculated to replicate stored data. These parity bits will be stored on separate drives than where the original data was stored. For example, if data is to be striped to drive 1, 2, and 3 here, then the parity bit, which will allow you to replicate that data if this drive fails, will be stored over here on disk 4. That's where the parity bit is going to do. So this will allow one disk failure in your RAID configuration because these parity bits will be able to recreate that data that you lost over here on A2. RAID 6 operates the same way as RAID 5, but just more parity bits, allowing for more redundancy with drive failures. Disadvantage, slower write performance, and of course less storage space because those parity bits are taking up an area where you can also have storage, right? And now let's move on to our last RAID we're going to talk about, RAID 10. RAID 10, you get the best of both worlds by combining RAID 1 and 0. But with RAID 10, you're going to need plenty of disks to get the desired advantages. So you get the striping speed, but also the redundancy of mirroring. All right, now let's move on from RAID and let's go over some network redundancy or redundancy in your network. So storage redundancy is essential for your sensitive data and critical applications. And as a security administrator, your organization's network infrastructure is also crucial for that. So we went over different ways to have redundancy and resilience for our storage, but now how do we create redundancy within our network? Well, let's get into that. So one thing we can implement is a load balancer. A load balancer is a piece of hardware that sits in line with your servers, maybe like a web server farm, and can distribute network connections to not overload or saturate client connections to your enterprise or internet-facing servers. So this will allow all the hundreds of users that are connecting to a web server to be load balanced amongst this entire web server farm. And then we have NIC teaming. NIC teaming is going to describe link aggregation, which essentially means, let's say you have a server here and it's connected to a switch. And on the back of that server, you're going to have a NIC there, a network interface card, with 4 1 gigabit Ethernet speed connections. Well, what you can do is logically combine all 4 of these physical ports into one logical interface. And when it's connected to that switch, you now get those bundled speeds and you get higher bandwidth. So if each one of these was 1 gigabits per second, by combining all 4 and making one logical interface, you now get 4 gigabits per second of bandwidth. And that is called NIC teaming, right? When it comes to servers. There's other names for this. If you're a network guy, you know Ether channel is a term for it. Port channeling or port channel. Lag, which stands for link aggregation grouping, or just link aggregation. They all essentially do the same thing. They take multiple physical ports and combine them to make one logical port. And the last thing we're going to talk about is power. So we talked about how you do redundancy for your storage and your networks. But let's go over the last form of resiliency we must have in our networks, which is power. Power, without it, you're done, right? Power goes out, you're down. So power must always be continuous and steady to ensure our infrastructure stays online. One piece of equipment Sec Plus wants you to know about and that we can implement is something called an UPS, or an uninterruptible power supply, which essentially acts like a big battery that takes over power requirements when our steady or short power goes offline. UPS can also keep the power steady during brownouts. So if you're somewhere where there's rolling blackouts throughout the city and it makes your systems come up and down, that UPS can save you from that. UPS can also be part of a network monitoring system if they have Ethernet or network connections. So some advanced UPS you can also monitor for their health. All right, so that is it for this section. I want to thank you for viewing and stay tuned for our next video where we will go over domain 2.6 embedded systems. Thank you.